10 minutes.
Okay.
Great. Hey everyone, a wonderful evening, a wonderful morning. Wanted to shoot you a quick update on this batch overflow issue that's kind of, hitting, well, a couple of ERC20 tokens, and more than initially thought. It's actually talks about 12, 13 tokens where it's possible to create tokens out of the blue. And so what I want to do in this really short video is, on the one hand, explain how this batch overflow works from a technical perspective, and then I want to talk about how this is going to affect Ethereum, and or if this is going to affect Ethereum, and whether we at 10x are affected. If you come in, do me a quick favor, give me a thumbs up for this video, drop me a line where you're coming in from, and share this video if you like what you see. So let's talk quickly what happened. Basically, an ERC20 token is nothing else than a smart contract on Ethereum, which is a computer. And so there's some code that defines how these tokens work. And pretty much all these tokens have a function that you can't create tokens out of the blue. So basically what this smart contract checks is that if you basically look at the amount of tokens before and the amount of tokens afterwards, there should be zero difference between those two tokens, between those two numbers, because you shouldn't be able to create these tokens out of blue. And pretty much all these standard contracts that are out there, they do this in a pretty elegant way, and we're going to look at how this works. But then there's a couple of tokens that seem to be coming from the same developer, from the same firm, and it's just really strange that in all these tokens, there's a function in there that's faulty, and it allows people to create tokens out of the blue. And this is obviously a big problem because the price of this beauty coin, for example, that was depicted crashed by minus 99% because people created trillions and trillions and trillions and trillions of tokens. And it's actually not only a problem for this coin, it's a problem for the entire ecosystem, because this thing could spread over to other coins, and that's why all the exchanges stopped depositing ERC20 tokens, because it was really, really insecure on, well, where do these tokens come from? How does this work? What's the deal there? And this is obviously something that's quite, careful, quite a challenge to look at. But it looks as if it's under control, and it looks as if it doesn't affect the majority or the major important tokens. So actually, for example, 10x is not affected, but that's, first of all, we did proper audit on our code, just like most of the other companies. And also on the standard codes, if you go to GitHub and you look at the just standard kind of ERC20 code, you will also see that this is absolutely fine. So let me briefly explain how this batch overflow actually works. I want to give some credit here to one of our developers here in 10x, Mauro, because he was the one who kind of explained this to me in very simple terms on how this actually, well, happened in this case, right? And so I kind of want to pass this on to you. Basically, a batch overflow is a simple integer overflow. And what this means is that a computer, out of the code, is not capable, or it is, but it just takes a lot of computing power to basically check everything and all the time. So what you try to do as a programmer, you try to simplify things as easy as possible to kind of optimize things, right? And so there's a couple of optimizations you can do. First of all, you do optimizations in that the computer doesn't have to check all the kind of integers, so it doesn't have to check 1,000 integers, it maybe checks a certain number. And also that it doesn't have to check all the time, but maybe it checks after a certain operation, so for example, after an addition. And so imagine it this way. Imagine, and we're going to simplify this now, imagine a computer can only check 3 digits, right? 3 digits. And it checks that those 3 digits are 0. So imagine at the end of an operation, there's 300 there. And 300 means, let's say, 300 extra coins. So 300, there's a 3 here, so from my side, right? You have to look from my side, so this is the very left. 300, 0, 0, 300 larger than 0, so it gives an error, and it says this operation is not allowed because obviously you created 300 coins with this transaction. Okay, so that's 300. Now imagine you create 700 extra tokens, 7, 0, 0, 700 larger than 0. But now imagine this. Imagine you batch those two transactions together, 300 and 700. And they get added together because the computer wants to optimize. Then what happens is there's a 1 here for 1,000, 0, 0, 0. The computer is not checking that digit because by definition it only checks those 3 digits. And so now the computer says, good to go, 0, there's the same amount of tokens as before. And there were 1,000 tokens created. And this is how there's such a large amount of extra tokens in these very rare cases created that now suddenly are in this ecosystem and made the prices drop because of this integer overflow issue that could easily have been resolved. One of the simple issues to resolve this is something called safe math. And what safe math basically does is it asks a second question. It doesn't only check those 3 digits, it asks the entire number, is it larger than one of those figures that get added together? So it doesn't need to know the entire number. It just looks at the numbers that are there. Are they larger? Is it larger than one of its components? So 700 and 300. And what's here? 0. So it can never be that the result of an addition, if you have only positive components, is smaller than its factors in between, right? So 700 or 300, the result needs to be larger than one of those components. That's, for example, what a library safe math kind of checks. And that would be a very easy and simple addition. And this didn't happen in this case. And this caused a lot of problems to 12 or 13 different coins. So what does this mean? Well, it means for you to, well, kind of trust coins of companies that use proper auditing and maybe do public auditing and use maybe, well, renowned kind of firms or can code inside. So that's why I always look for a team with great developers. This is so important because now looking at this, right, even myself who's not a great programmer can look at this and understand it and explain it to you. But if you gave me all the lines of code and asked me, find a mistake, I'm not going to find it, right? I don't have enough practice. I'm not an expert in this. That's the key part, right? So even though I have these basic programming skills, I understand these things because I can talk to the developer and they can explain this to me and then it makes sense to me. But I couldn't find this. So you need to have someone who's really good at this, right? Like, for example, we have people in our company who are outstanding at that stuff. That's the first thing. The second thing is, obviously, you don't just want to go in panic mode. The market right now is overreacting a bit. And so Ethereum is not in a systemic trouble. I don't think that's a problem. I think maybe right now is a good time to buy a dip, for example, right? And yeah, and the third thing is know these things, take them a bit with, learn something every day. And I think that's always interesting. So I hope this short video explains to you how such a batch overflow actually works, what it does, how it could have been avoided. A bit technical today, but I think that's absolutely fun. Don't worry about, I don't think it's going to have any deeper issues. If you have any questions, let me know in the comments below. And yeah, please give me a thumbs up for this video. If you're completely new to this, get my book, Cryptocurrencies Explained Simply. If you are interested in making your crypto spendable, then check out 10x. Links and everything is down below. I'll see you at the next video. Thanks so much. Yours truly, Julian. Bye-bye.